and how to do this problem here. Okay, so our goal is to create a sine function for this wave that we see here. And usually what you want to have with you as you're creating these equations is first off, your parent function, and also any formulas that you should know for this. The next thing that I'm going to do is I'm going to go ahead and describe how I found that the amplitude of this particular function is 2. So step 1, in order to find amplitude, what you need to do is draw your midline. Your midline is the line that crosses through your wave horizontally and equally. So it looks like it's right about there. So after I've drawn my midline, I go ahead and I count the distance from the midline to a peak. So the distance of this right here, what is this distance? Now be careful, you don't want to count the squares. What you want to look at is here. Our scaling is right here on the side, so be careful with that. So we go from 3 to 5. So that means this right here means our amplitude is 2. So be careful there, because I noticed that as a common misconception. So that is how I found my amplitude to be 2. And go ahead and clear this up. So that was how I found amplitude. I think I'll keep my midline there. Now let's move on to finding the B term. See, I found A, let's move on to B. Usually when finding the B term, I use this period formula. So the period of a function is equal to 2 pi divided by absolute value of B. Remember, y'all, absolute value is basically just makes whatever number you have positive. Okay, so first, in order to determine my B value, I need to figure out what the period is of this function. So I'm going to go back to my strategy and technique. In order to find the period of a function, you measure the distance from peak to peak. So this is the distance here, and this distance is going to be the period. But what is that distance? Well, we just go down to the x-axis and measure the same distance. Our x-axis is basically acting like a ruler. Even though I did this crookedly, I see that that distance there is represented by pi. So the period of this purple function is pi. And that's not where we're done, right? Our goal was not to find the period, everyone. The goal was we need to find B. In order to find B, we needed pi. So sorry, that arrow could be confusing. So in order to figure out what B is, we do need that pi. Let me show you though where this comes up. So I'm going to be using this blue formula right here. So because period is pi, right, y'all? The P becomes pi. So the formula is essentially P equals 2 pi over B. But instead of writing P, I replace the P with my pi because that is the length of my period. So I have this. And our goal, once I have this set up, our goal is to solve for the B term. We want to figure out what is B. Okay, cool. So this is the strategy. To kind of solve for B, what we need to do is we need to put pi over 1. Once we do that, we can cross multiply. So that's what I'm going to do next. We're going to cross multiply. And again, the goal is to solve for B. So I'm going to cross multiply like so. Okay, so let's cross multiply. And once I do that, this is what I get. I get pi, absolute value of B, equals 2 pi. Now to solve for B, I need to divide both sides by pi because that's pi times absolute value of B. Opposite of multiplication is division. So I'm going to divide both sides by pi. And I get that the absolute value of B is equal to 2. So because our answer could be negative or positive 2, I'm just going to say my B is the positive version. Both ones will work. So I'm going to say B is just going to be equal to 2, positive 2. next. And this answer already popped up right here. But nextly, let's figure out what my C would be. And we already got B, so let me erase this question mark. We know that B is now 2. Okay, so in order to figure out what my C term will be, I'm going to be using the phase shift equation. Well, first off, this is my parent function, and it starts at 0, 0. And phase shift basically tells us if there's any horizontal shift. That means if your x value is different where you start off in your sine function. So I noticed that this sine function starts right here, and it specifically starts at 0, 3. Notice how the x value is still 0. That means there was no side-to-side shift. This function did move up from the parent function, but it did not shift side to side. So C is going to be equal to 0. Because there is no phase shift, your C is just equal to 0. That makes the C over B as my phase shift. That's going to just equal 0. So my C was 0, and this 2 came from the fact that B was 2. But 0 on top divided by anything just gives us 0. That's why this now is 0. All right, lastly, vertical shift. Basically, your vertical shift is you just look at the location of the midline. My midline right here is at +3, so my D is just going to be 3. So we have A is 2, we have B is 2, we have C is going to be 0, and we have D is equal to 3. We have everything we need. So we go ahead and we plug it in right here. And we plug in our parameters and we simplify this to y equals 2 sine of 2x plus 3. So that